environment really was an integral part of how the farm was set up. It was set up as a best practice farm and with strong environmental monitoring and measurement that you've heard about. So that's become really an underlying part of our best management practice type of farming, where we are very careful on our inputs and the effect that's having. Now that's a combination of inputs, pasture management, irrigation management, making sure that our off-site effects are as low as we can possibly get them. I believe we have got a sustainable operation here. We know what the inputs are, we know what the outputs are, we're tracking them carefully, we're adjusting accordingly, and I think in the scheme of things, we're as well positioned as we can possibly be. We're taking a few new initiatives this season. We're looking at our what you might call environmental footprint in terms of carbon and modelling that. And that's part of a benchmarking process, so we can actually make some improvements year on year to where we are now.
Well, the system we have on place on the Lincoln Dairy Farm involves, first of all, an intensive soil sampling program. So we soil sample annually. We have a total of 18 transects or lines set up with GPS right across the farm, and we return to these transects every year and soil sample them in June. So that's really the first step, is to do an assessment of current soil fertility on the farm. We then use that information from the soil testing results. We plug the numbers into Overseer, nutrient budget, and that gives us quite an accurate assessment of the nutrient requirements, fertiliser nutrient requirements annually for the dairy farm. If we wish, we can input different numbers for different types of farming systems or different scenarios into the nutrient budget to see how those changes change nutrient loss from the system. The Overseer and nutrient budgets of its type are very valuable tools for a farmer to assess nutrient loss, but also to assess those annual nutrient requirements to maximise production, but yet not to over-apply. And I think that that's also very important, because if we over-apply, we get less return on our fertiliser dollar. And I think one very important aspect of using nutrient budgets is to really get down to the nitty-gritty of how much nutrient is required as fertiliser, and therefore maximise the returns or value you get from your fertiliser dollar for maximised production. And the nutrient budget is a very valuable tool for doing that. Overseer has a positive effect on the bottom line for the farmer, because we can assess nutrient requirements accurately for the farming system, not over-apply, and therefore achieve maximum production for the fertiliser dollar.
From the concept stage for Lincoln University considering converting what was a sheep farm into a dairy farm, we wanted to ensure that we measured the effects of that conversion. We therefore put an environmental objective at the centre of our business plan to ensure that we were able to achieve best management practices under irrigation and at the same time protect the environment. We've done this by installing our wide range of environmental monitoring systems. The first of those is a series of wells which we've drilled into the shallow, unconfined or open aquifer that's at between 4 to 8 metres below our feet here on the North Block. We take water samples from these wells each month, and we are measuring the presence or absence of any microbial contaminants in that water. The reason for this is that the North Block of the farm receives the effluent from the farm dairy. We want to recycle the nutrients from the farm dairy, very valuable nutrients, so we therefore want to recycle those back to the land that the nutrients came from. And at the same time, we want to do this in a sustainable way so that there's no adverse impacts of bugs entering the aquifer below. So we have wells on the western boundary of the farm, in the centre of the farm, and on the eastern boundary of the farm. The microbiologists at ESR tell us that there has been no significant contamination of this shallow, unconfined aquifer over the past 5 years since conversion of the dairy farm. And we think this is an excellent result because it shows that the method of management of the effluent and the effectiveness of the soil means that any bugs that are applied in the effluent are being filtered out by the soil. The soil is a very good filter for water. The farm receives superphosphate fertiliser during the year, an application in spring and an application in autumn, and we also use urea fertiliser. And on the areas that receive the farm dairy effluent, we do not apply any urea fertiliser. There is enough nitrogen in the effluent from the farm dairy to supply the needs for the plants in that 28 hectare area. We're measuring the leaching of nitrogen from the Lincoln Dairy Farm using lysimeters. Lysimeters are large columns of soil which we've collected very carefully to retain all the natural structure, all the plant roots in the soil profile. But they're in a drum which is 1/2 metre diameter and 1 metre deep, and we have installed 60 of these on the farm. The cows graze those lysimeters, the irrigation runs across the lysimeters, the fertiliser truck drives across the top of the lysimeters. And we're able to collect the water from each individual lysimeter to measure how much nitrogen is leaching from this dairy farm. But on average, over the past 5 years, we've been losing around about 20 kilograms of nitrogen per hectare per year. That's a very low loss from an intensive dairy farm system. Measurements of nitrate leaching from dairy farms in New Zealand, anywhere between 10 to 50 or 60 kilograms of nitrogen per hectare per year. Some cases it might be slightly higher, but the average would be around 30 to 50. Yeah, our leaching losses are currently at 20 kilograms of nitrogen per hectare per year, which we're pretty pleased with. Most of the nitrate leaching comes from the urine that's deposited by the cows, and that's simply because the grass that the cow digests, the nitrogen in that grass is mostly excreted in her urine. And those urine patches are equivalent to 1,000 kilograms of nitrogen per hectare. And to try to address this, we've been working on the development of nitrification inhibitor technology to reduce the leaching loss from those animal urine patches. And this has been shown to be very successful.
A nitrification inhibitor is a very simple compound. It's called DCD that we've been working with. And what it does is it slows down the conversion of the ammonium in the soil to nitrate. And it works by deactivating the enzyme that is responsible for the conversion from ammonium to nitrate. It doesn't kill the bacteria, and with time it is gradually broken down into simple compounds. So it doesn't leave any long-term residues in the soil, and it's a very safe compound. It is actually 3 times safer than the table salt that we eat every day. It's registered as a fertilizer, in Europe, in North America, so it's not regarded as an agrochemical. We've been working on nitrate leaching for a number of years. Trying to look for solutions to reduce nitrate leaching losses. Nitrate leaching from the greased part systems mainly comes from the urine, not from the fertilizer. Very often over 90% of the nitrate leaching comes from the urine. As the cows ingest the pasture over the paddock, and between 70 to 90% of the nitrogen is returned to the pasture in the excreta. And of that, up to 80% is in the urine. So the nitrogen loading rate under the urine patch can be as high as 1,000 kilograms of nitrogen per hectare.
The inhibitor is applied in May and again in August, and the aim there is to hold the nitrogen in the soil profile where it can be utilised by the plants, but at the same time make sure that it doesn't leach out into the drainage water or come off as a gas. Through the use of this new nitrification inhibitor technology, with strategic use and careful use of nitrogen fertiliser and very efficient irrigation, we have measured significant reductions in nitrate leaching from the Lincoln University Dairy Farm. The reductions are in the order of around 50% for this dairy farm.
Yes, the Lincoln Dairy Farm, the detail of work there has shown clearly that nitrification inhibitors are effective at reducing leaching loss. That is in an environment that's relatively low rainfall with controlled irrigation, and there is work that has been done in other parts of the country that have shown some differences. The work in Southland and lower rainfall have given similar results to Canterbury, while in the warmer parts of the North Island and where there's higher rainfall and coarse draining soils, such as the pumice soils around Rotorua and Taupo, the reductions in leaching from use of inhibitors have been lower, for example of the order of 20 to 30% instead of more like twice that in the South Island. The measurements that have been made with nitrification inhibitors around different sites have shown much less difference in terms of reducing nitrous oxide emissions, which is one of the main greenhouse gases. And so there appears to be more uniform in terms of their reductions, and in fact of a greater magnitude than that to leaching, where, for example, numbers in whole graze systems of 40 and 50% reductions in nitrous oxide appear to be common.
Other farmers using nitrification inhibitor technology, the same as we're using at Lincoln University Dairy Farm, and with good strategic management of the nitrogen fertiliser and good irrigation practice, could achieve a very significant reduction in nitrate leaching losses, similar to what we're seeing here at Lincoln University.